So today we're looking at graphing of the radical functions. So as it says, radical function is a function that has a variable under a radical symbol. Okay. So you know how we've been graphing like x squared, and if that's just plain parabola, and we call that the parent function. It's the same thing with the radicals, right? So for this first one here, we're just looking at square root of x. So that's what we would call the parent function in this case. And before we start graphing, I'm just going to set up an XY table for this, just to get us started here. Okay, so if I've got the square root of x, what would be some good values of x to plug in? 0. That's a great one. And the square root of 0 is 0. So we'll plot that one. Okay, what else would be a good value? 4. And the square root of 4 is 2. Okay, what else might be a good value? 9. And the square root of 9 is 3. So then that comes a little bit off of my grid, but that's okay. Okay, so at this point we're going to start going off really far. What other value that's on the grid was pretty good? 1. And the square root of 1 is 1. Okay, so as we can see, we are growing pretty fast, but in the horizontal direction here. So we'll connect this. It goes on forever there. How about the other direction? Can I do -1? No, because square root of -1 is I. It's imaginary. And so do our imaginary values show up on a normal XY grid? No, they don't. Okay, so that means this is going to be, I guess you could think of that as the start point of the square root of x, and then it goes on forever in the positive direction. So when we talk about the domain, how would we want to state the domain? Yes, 0, infinity. Is it hard bracket? On infinity?
No,
soft.
Sorry.
Yeah, always soft on infinity. Okay, so that's the interval notation, or if we did the other notation, we could say x is greater than or equal to 0, right? Okay, so again, that's the parent function for square root of x. It doesn't ask for it, but why don't we go ahead and mention the range too? What is the range? Same thing. Yep, 0 to infinity. Okay, so the other parent function we want to look at is the cube root of x. And again, I'm going to go ahead and set up an XY table and plug some values in. Okay, so yes?
Wait, for the first one, can the y values be negative?
Not on this parent function the way that it is. Yep. Because it's only going up and to the right. So it'll depend on if you have a reflection or some sort of a transformation. Okay. So for our cube root, what are some good values of x to plug in here? 0, always a good one. And the cube root of 0 is 0, so we'll put that in, plot that there. Okay, what else would be a good one? 1. The cube root of 1 is 1. Okay, what else might be good? 8. Because the cube root of 8 is 2. All right, so again, that's going to take us off our grid here. So we see we're going this direction. Okay, so far we have considered everything to the positive direction. What about the negative direction? -1, right? Can we have the cube root of -1? Sure. Cube root of -1 is -1. And so what else would be a good value to plug in? -8. And the cube root of -8 is -2. And so we end up going in this direction as well. Okay. Does that remind you of anything?
Oh, wow.
Looks like, yeah, the cubic one, but just flipped. And then how about the square root one? Does that one remind you of anything? Yes, but only half of it, right? So it's only like half of it, exactly. Okay. How about the domain on the cube root? Do we have any restrictions on our x's? No. So therefore we would say -infinity to +infinity. And then I'll go ahead and add range in just because. Any restrictions on the range? No, no restrictions on the range. Okay. And actually, I want to be a little more specific about when we talk about the range on the square root. This is going to be dependent again on the function itself, but the parent function starts at 0. Okay. Everybody's favorite, transformations. So, what is the beauty of transformations on radical functions? Do the rules change? No, it's the exact same rules. So, the exact same things that we did at the beginning of the year, those same rules will apply here. Okay, I'm going to start by I'm just going to put little x's for the parent function in here. So we had 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so that is the parent function. So now let's look at this transformed function where we have square root of x minus 3, where the minus 3 is under the radical and the plus 4 is on the outside. And do we remember what that tells us to do? Yes?
Right 4 and
Right, how many? Right 3 and up 4. Okay, so again, you want to take care of what's under the radical first, right? So even though it's not really parentheses there, we think of it that way. But you can also think about its parentheses then exponents. And what do we know the square root is? Square root of x, is that an exponent? Yeah, it's just being raised to the 1/2 power. Okay, so again, take care of what's on the inside first. So we'll start with horizontal, shift, right 3, and then as she said, a vertical shift up 4. So I'm going to go off the little x's that I created in my parent function and taking my 0, 0, going right 3, 1, 2, 3, and then up 4. 1, 2, 3, 4. So there's the new one. And 1, 1, go right 3, 1, 2, 3, and then up 4. 1, 2, 3, 4. And I can fit this last one in. That's at 4, 2. We go 1, 2, 3 right and up 1, 2, 3, 4. And there is our transformed function. I'm going to go ahead and include domain in here. What would be the domain of our transformed function? X is greater than or equal to 3. or in interval notation, we would do a hard bracket 3 to infinity. Okay. And our range was also affected. What's our new range? I just hear whispers. 4 to infinity. Yes, and hard bracket on the 4 because that value is included. Okay. All right. Okay, ready to look at the next one? All right, so this one is g of x equals the cube root of 2x. All right, so again, I see that it's a cube root. I'm going to go ahead and put little x's in for my parent function. So I have 0, 0, 1, 1, 8, 2, -1, -1, and -8, -2. Okay, so there's my parent function in. And so now I've got cube root of 2x, and the 2 is under the radical being multiplied by x. So what do we say is that transformation? How do we describe that one? Horizontal shrink by 1/2. Everybody remember that? That looks like an H, doesn't it? Okay, and so remember, when we say we are working on a horizontal stretch or shrink, you're multiplying the x term by the factor, all right? So, looking first at my 0, 0, when x equals 0, if I multiply that by 1/2, it stays 0. So that one didn't move. And then in my next one, x equals 1, if I multiply 1 by 1/2, that's going to take that in here. My next one, x equals 8. 8 by 1/2 takes it down to 4. Okay, and then the same thing is happening on the other side. -1 goes to -1/2, and -8 goes to -4. And then we'll just connect the... And we want to make sure that we connect these in a smooth curve. I'm going to go ahead and add domain on here. Any restrictions on the domain? No restrictions, so we'll say -infinity to +infinity. And how about the range? No restrictions there either, so -infinity to +infinity. Okay, so here are 2 of them for you to try. Added some negatives back in there. I know it's been a while, but I think you guys can remember how to do it. So make sure that you describe the transformation and then also plot it. Okay, so there's the first one. Frozen down. There we go. So I think the biggest thing I noticed was not doing the correct order of operations. Okay, so remember, what's inside first, and then multiplication before addition. Any questions on this one? Okay. And there's the second one. Which ones do you guys find easier? Was that this second one? You thought the top one was easier? Okay. So I guess it's all about preference. Okay, any questions on these? All right, so was there a question? Okay, so this next part is really, really straightforward. Okay. These two, it's simply giving us equations or functions and asking us to find the domain. All right, so when we're doing these, it's not necessary to start solving or anything. All we're going to do is look at the function and we kind of ask ourselves, are there any restrictions on cube roots? Exactly. There are no restrictions on cube roots because you can have negative values and positive values. No restrictions. And if there's no restrictions, what does that mean for the domain? It's all real numbers. So the domain, negative infinity to positive infinity. All right, so again, there's nothing to solve here. You don't have to graph it and look at the graph or anything. Just consider it. So would the same hold true for a 5th root, 7th root, 9th root? Yes, there's no restrictions on those odd roots. Okay, so versus if I look at that one there, this one here, I have the square root of, or actually I have the negative square root of x minus 3. Same thing. I'm going to say, are there any restrictions on square roots? Okay. And yes, there are restrictions. What is the restriction on a square root? The domain can't be negative? What's going on when we look at this? What value can't be negative? The radicand. What's the radicand? It's what's inside the radical. Yes, that's the restriction. The radicand cannot be negative. Can the radicand be 0? Yes. So the radicand must be greater than or equal to 0. So if I'm trying to find the domain of this function here, what's the only piece I need to look at? Just the radicand. What's my radicand right now? It's x minus 3. X minus 3 is the radicand. I will set that greater than or equal to 0. And now can I solve for x very easily? Yes. What does x have to be? Greater than or equal to 0. So the domain of this function, 3, thank you. Add 3 to both sides. Okay. All right, so the domain of this function is going to be from positive 3 to infinity. Is that going to hold true for 4th roots, 6th roots, 8th roots? Exactly. Okay, so even if you were given something like, say, f of x is equal to the 4th root of 7x minus 3. And you were asked to find the domain. What are we going to do? Exactly. 7x minus 3 is greater than or equal to 0. Solve for x. 7x is greater than or equal to 3, so x has to be greater than or equal to 3/7. Okay, and again in interval notation, that would just be 3/7 to infinity. Okay, so again, there's nothing to sketch or draw. There's nothing fancy to solve. It's a simple matter of taking the radicand, and only the radicand, and set it greater than or equal to 0 and solve for x. Okay, that's it.